discuss in 6th unit. 6th unit talks about what is the relation between your probability and AI, and then it talks about what is a conditional probability, and then it talks about some Bayes theorem, Bayes theorem, and extended Bayes theorem. So if I wish to work on this particular certainty factors, you have something called as certainty factor theory. Which will tell you like how can we believe a statement, what is the amount of belief, what is the amount of disbelief of a statement. Based on that we can move from one state to other state taking some decisions. And the most important thing is Bayesian belief network. Bayesian belief network is very important for people who wish to work on this, how the probability is related in taking some certain decisions without a complete data. And Dempster's Schaeffer theory is there. It is a story, it is a theory that how can we make conclusions from set of statements. So among all these things, the Bayesian belief network is very important for people who are aspiring for research or people who are working in artificial intelligence. And then certainty factor theory also it will tell you like every statement you have some hypothesis that has to be proved. Then how do you compute the measure of belief that support of that particular hypothesis or measure of disbelief? How do you compute? This is what we do in certainty factor theory. You have some set of equations, we'll just remember them and then conclude. Dempster-Schaeffer theory is a theory where you have set of stories. Like A has done a crime, like if there is a crime that was happened, that crime is a murder story. And three people, A, B, C, are the people who may be involved in that murder. So A has some alibi, B has some alibi, C has some alibi. What is the probability that A has done? What is the probability that B has done? And what is the probability that C has done this particular crime? And what is the probability that all these three may not be involved in this something like that? This is a story. And there is a wife and there is a husband. There is a story about that. That is what we talk about a Dempster-Schaeffer theory. A Bayesian belief network is a concept where we try to draw a DAG, a directed acyclic graph that you have seen in these data structures and DAO also. Like this DAG we create. How do you draw a DAG? DAG we draw without cycles and based on some relations like dependencies will draw this DAG diagram. If there is no dependency, that will be better. If it is dependency, you will have to nodes and so on and so forth. Bayesian theory, a Bayesian theorem or extended Bayesian theorem, you have already known this conditional probability and how this probability is related to A because every time what is the outcome of artificial intelligence in general is prediction. So whenever there is a prediction, so we cannot say that we cannot guarantee that whatever we have predicted is guaranteed until unless that event happens. So that is the reason every statement will have some probability that that will be augmented, and the probability will increase or decrease with respect to time dynamically. So at some point of time, I have a statement saying that the symptoms attributed what I have given is fever is zero point 0.4. Then this 0.4 may increase to 1 or the zero point 0.4 also may decrease to 0 or 5 or whatever to 0.6 or something like that. It depends upon what type of support that you have in the terms of belief and disbelief of the statements that we have given. So it's very simple unit. What is that we do is we'll just try to recall what we have learnt in probability earlier during that. And did you remember some what is the formula for joint probability? Like we have something called as joint probability. What is that? Can somebody just tell me what is joint probability? What is the formula for P of A intersection B?
P of A plus P of B
See,
minus P of A.
yes, yes, it's very simple that you write like this. Probability of A into probability. What you said is right. And we have to say something like B has already occurred. What is it? We call it as conditional probability. What is this conditional probability? What is the probability that A will occur if given that B has already done completed?
P of A
Then
intersects
what is the
B.
formula
P
for
of
this?
P
A
of A
and
intersects
P.
B by P of
What is said is right. What is the chance that A will occur given that B has already occurred? Is probability of A and B. And they will ask you like what is Bayes' theorem? Like mm, Bayes' theorem is very simple. What is P of if you A by B Herten? What is P of B by A? P of A intersection P by probability of A. So from this probability of A intersection, B can be probability of B by A into probability of A. So if I use this here, like probability of what is probability of A by B is nothing but this is already till there. So probability of B by A into probability of A by probability of B. Is this right? So this is what we call it as Bayes' theorem. That you have already seen this in your probability. Extended also you have seen. And even in the last unit, because we have framed a very little syllabus, they will ask you what is Bayes' theorem, what is this conditional probability, then you have to explain with respect to an example. They will also ask you what is the probability of A provided B has occurred and C has occurred, then you can write the extended Bayes' theorem, something like this. Like extended Bayes' theorem. Like what is the probability that A will occur if given that B has occurred and C has occurred, you can write something like P of B by A into has occurred. C has also, so I can write C by A into probability of A my probability of B intersection C because they said both has happened. Something like that. They will ask you what is the Bayes' theorem, what is the extended Bayes' theorem, what is conditional probability, and then they can also ask you what are the joint probabilities. Then whatever they have asked, you can relate them by using an example, and then we can proceed. Then certainty factor theory is a theory, that is what it is. So certainty factor theory is very simple concept that that can be understood very easily. What will happen if every statement will have like I have a statement to be proved. So what will happen if you augment this belief to the statement and disbelief? We have set of formulas for this one, like amount of our belief. All these values will be in between 0 and 1, you are aware, because probability values also will be in between 0 and 1. These values will be in 0 and 1. But you have certainty factor, like, see, have a certainty factor theory. What they do is, certainty factor theory is very simple. Certainty factor theory, what does it, it will tell you is like, if I wish to find the certainty factor for a particular hypothesis, if this is the evidence that they have given, what is that we need to compute is, we need to compute the measure of belief of H comma I, hypothesis and this evidence, minus measure of disbelief of H comma I. That's what they say. This is what they call it as certainty factor theory. So what is the measure of belief? Measure of disbelief. This is how you compute the certainty factor. That's what the theory that they said. And still, if you further explore what is this measure of belief, if you see the textbook, you have set of equations like this. Measure of belief, you wish to prove hypothesis, and you have a set of evidences like S1 and S2. The formula that you have to remember is, measure of belief will be 0 if disbelief is 1. If measure of belief will be 0, because if disbelief is 1, obviously this belief will not have any value. So if measure of disbelief of H comma S1 and S2 is 1, then it will be 0. If measure of disbelief of H comma S1 and S2 is not 0, then you have a formula called as, when it is not 0, then you have a formula like measure of belief of H comma S1 intersection S2, that this is the hypothesis to S1 plus measure of belief of H S2 into 1 minus measure of belief of H S1. This is a formula that you have to remember. Same way, if you wish to compute the measure of disbelief of also H of, if there is a hypothesis H and you have two evidences that are there, this measure of disbelief also is 0 if measure of belief of the same hypothesis with these two evidences is 1. So the same way we'll compute this measure of disbelief of, if it is not equal to 0, then we have the same formula, measure of disbelief of H comma S1 intersection S2 equal to measure of disbelief of H, if this hypothesis has to be proved, plus measure of disbelief of H comma S2 into 1 minus measure of disbelief of S comma S2. These are the formulas. Like, this is a certainty factor theory. What they do is, irrespective of randomly assigning a value, while we are writing a program, what is that we do is, by default, the certainty factor for every statement, we take it as 0.5. So when there is an evidence to our credit, what is that we do is, will that 0.5 will be incremented to 0.6. If the event has not happened, we'll decrement that to 0.4 or something like that. It depends upon how do you evaluate or how do you write the code. But here what they said is, when certainty factor theory was a certainty factor you have considered, you need to consider both belief and disbelief of a statement. with respect to the fact that H has to be proved. You have evidence one or two, whatever it may be. So the belief and disbelief also will take values between 0 and 1 because they are also probabilities. Then they say, how do you measure this belief means? This is the formula, and this is how the disbelief means. This is the formula. That's what they have given. So if somebody asks you what is a certainty factor, you can just write the formulas and you can explain the same with an example. This is joint probability. Okay. Can somebody just tell me what is a directed acyclic graph that we do in DAW as well as these data structures? Can somebody just tell me what is this directed acyclic graph? And what is the basic difference between a graph and tree?
Tree is hierarchical structures.
Which is closed?
Graph is
The
closed.
graph is closed or tree is closed? Graph is closed. But
Graph
this
is closed.
DAG is a directed acyclic. Yes, what you said is right. DAG is a directed acyclic graph, but what is the specialty is it does not have any cycles. So what is that I'm just trying to tell is I'm talking about a Bayesian. We're talking about something called as Bayesian belief networks. If I wish to draw a Bayesian belief network, which is theoretically important in the context of artificial intelligence, what is that we need to do is we need to draw something called as DAG, directed acyclic graph. So from that directed acyclic graph, we will apply this conditional probability to now predict something. So we will take a small example, then we'll come to this. So if it is windy, is there any probability that you will have rain? Is it right? Like if it is windy, is there any chance that you'll get a rain? Can somebody just respond? If there is a wind, is there any chance that you'll get a rain? There is
Yes.
a heavy wind,
Yes, sir.
so can we predict rain? Yes,
Yes,
yes.
sir.
Okay. If there is a cloud, like assume that you have your this is cloudy, is there any chance that you'll get a rain?
Yes, sir.
Yes,
Yes.
sir.
So what is that you're trying to do is you're trying to have a set of statements are there, and you are finding the variables which are dependent on each other. So at this moment you said rain is dependent on wind and cloud. Is it right? So assume that there is a rain. If there is a rain, assume that if there is a rain, uh, assume that the ground is wet. So when there is a rain, there is a chance that the ground will be wet. And if it is raining, I don't go to the office, so I will take a leave. This can be an outcome. So what is the dependent variable? When can I take a leave? When can I take a leave? In general, when it rains. Is it right?
Yes,
When
sir.
there is a chance that you will get a rain is
And
if it is
cloud.
cloudy or it is windy. When when there is a chance that the ground can be wet is when there is a rain, and when there is a rain means if there is a windy across. So what is that we have to do is we have to you process the statement semantically, then you draw some diagram called as directed acyclic graph. with some relations. Like you just see how do you draw this now. See, there is an event called as wind or windy, whatever it may be, right? And there is something called as cloudy. So cloudy, I have written, I will write windy. So this wind and cloud at this moment, they are not dependent on any variables. So assume that rain is dependent on both. There is every chance that this rain can be there if it is windy. That's what I am assuming. If it is cloudy, also there is every chance that it rains. So rain is dependent on two events, and wind is an independent event, and cloud is an independent event. So you can have a probabilities of wind and just take writing something arbitrary here. The probability that it is cloud is 0.3 or whatever. So if there is a rain, I said the ground can be wet. So wet is there. So how many events on which wet is dependent on? How many events that rain is dependent on? Can somebody just tell me how many events on which this rain is dependent on?
Two, sir.
In two. So wet one or two?
One.
One. What you said is right. So this I said it is a leave or something. I have arbitrary time. So I can take a leave or I wish to take a leave when there is a rain. So this is an independent node. This is an independent node. What is it I have to do is yes. So that is an independent node, but the rain depends upon two values. Wet depends upon rain. So if somebody wish to compute the probability of wet depends upon rain, is it right? So what are the possible values for rain? The rain can be there, it is true, or it can be false also. So assume that I'm again randomly assigning the values here. Here there can be rain. Rain you have two possibilities only because it leave is dependent on only one. So this is F. So what is the probability of taking a leave is 0.4 and 0.5. Something I have written arbitrarily. It's not intentional. So this I said is independent. So this is having one value. This is independent. This is having one value. This is dependent on two. Wet is depending on only one, so it is having two values. This is dependent on one, so it is having two values. How many values that rain must have now? Because rain is dependent on two values here. What is the probability that you will have a rain or dependent on how many values? See, this wet can be determined only by rain. Rain can be there or rain may not be there. Leaf is dependent on rain. So the possibilities are only there may be a rain or there may not be rain. So here, but the rain depends on wind and cloud. So the probability of having a rain depends upon how many values. It depends upon wind value as well as cloud value. So how many values you will get? Is it two or four or one? See, sometimes it can be windy, sometimes it can be cloudy, sometimes it can be both windy and cloudy, sometimes it can be both, may not be windy and cloudy. Is it right or wrong?
Yes, sir.
Yes. So this can be true or this can be false sometimes. Sometimes this can be false, sometimes this can be true. Sometimes both can be both can happen. This can also happen. So you'll arbitrarily again I'm writing some point 0.3, point 0.4, point 0.5 and point 0.6. So what is that we need to do when you are constructing a Bayesian belief network is you try to understand what exactly the statements are. Then you find the relations. You draw a acyclic graph. Graph can have what is that cycles, but this acyclic graph, whatever we are talking in terms of DAG, will not have any loops. So it depends upon, see, if you have, assume that if you have some other dependency here, if there is something called as humidity, there is a rain. So how many values that you will have? Assume that rain depends upon three values. Then how many values that you need to compute here? Rain is dependent on three. So how many probability that you have to compute? See, when it is an independent variable, this is 2 power 0. When this wet depends on only one value, this is 2 power 1. So two values you have computed. When rain depends upon two values, you have computed 4, that is 2 power 2. When it rain depends upon this humidity also, how many values you have to compute? 2 power. See, sometimes there is a wind, there is a humidity, there is no cloud, there may not be a cloudy, something like, so all this, if I wind cloudy and there is a humidity, then you need to have this. So this, all this will come almost 2 power 3 and you have 8 variables here. This, I see it down there. So rain depends upon two dependent variables. So that is the reason we have computed 2 power 2. These values will be given by the people who have given this particular example. These values are written randomly, that when they have a problem, they will give you. That's not a problem. So these values they will give you. This value is called as WC. This value is W bar C. This value is WC. This value is W bar C bar, something like that. So this is how the first thing somebody asks you, how do you construct a Bayesian belief network? Then this is what we have to tell. You take an example, you get the dependencies, and these are the probabilities that you need to construct. So assume that how many leaves are there at this moment? For this DAG, how many leaves are there? Did they lost the connection or what? For this DAG, how many leaves are there? Am I audible?
Yes, sir. Yes,
For
sir.
this particular diagram, how many leaves are there? And how many outcomes are there for this diagram? See, for any, like you have something like this, you have a tree like this. A very big tree was there like this. So all these are leaves. So whatever predictions that we use, whether you use a decision tree or whether you use a DAG, the predictions can be done to this particular nodes only. So here you can compute the probability of being wet. Can somebody just tell me what is the probability of uh, getting wet? Probability of wet provided rain has happened into probability of R, plus there is a chance that probability of wet R has not happened, and probability of not having a rain. Still, if you further ask me to expand this probability of R, still change this. What is this probability of R? If you wish to compute probability of R is dependent on almost two variables. So then I have to write probability of R is equal to, so probability of R provided this wind and cloudy happens into probability of this WC plus the probability that both does not happen. This probability of wind and this both does not happen into probability of plus I will write here plus probability of R provided W happens and C does not happen. So then I have to write probability of W into C plus probability of R provided W happens and W does not happen and C happens into probability of, this is what you have to write. Still, if you wish to explore, you can explore and write whatever. There is a big extension for this Bayesian belief network that you can take up at a point of time. But what is expected in Bayesian belief network is, Bayesian belief network is the way in which you represent logical statements which are connected and related without any particular cycle. We call it as a DAG. So for creating a DAG, you need to find the relations. So you need to find out in how many, this is a node on how many variables it is dependent. It depends upon the, you know, success. Like you have a success here. So obviously in the top, there is no node. So windy is an independent variable. Cloudy is an independent variable. So rain is there. For this rain, wind and cloud are parents. So two parents are there. It depends upon two variables. Wet is there. It is coming from rain. So it depends upon one variable. It depends upon one variable and so on and so forth. So when it depends upon one variable, there is a chance that this true false can happen. When two variables, you can have true false, false true, and two true and false false. So when it is three, you can have two, three trues, three falses. All these two power three combinations will come. But whenever you wish to find out these probabilities with respect to probability of wet, you need to compute all this with respect to the top position is concerned. So when you find the probability of wet, you need to consider probability of wet R may happen, probability of wet R may not happen, something like that, and then you compute probability of R. So once you compute probability of R, everything will be there and you will get this. So when they give an example or they will give a problem, they will give all the values, then you can substitute the values and get the output. So the most important thing we have discussed is the last one, because every time they will ask you the last question, because Bayesian belief network will have a lot of extensions, almost 7 to 8 extensions are there for this Bayesian belief network. So that is very important. So I said about probability. Probability is vital because the data that we have, the database that we have in artificial intelligence is not static, it is dynamic. So every time we need to find out what is the probability that A will happen, provided B has happened already, or C has happened, or both are happened, something other. The condition probabilities play a vital role. So that is the reason we have discussed about the Bayes theorem and the extension of Bayes theorem when you have two or three events that has happened, something like this. Extended Bayes theorem when two events like BC has happened, provided what is the probability that A has happened. And conditional certainty factor theory, then how do you measure this belief and disbelief statement that you need to remember? And then we have discussed something called as Bayesian belief network, where you are trying to draw a DAG from the set of related items, where you need to find out what are the relations and how many events are event, how many events are dependent. Wind is an independent event, cloudy is an independent event. Rain depends upon two variables, wet depends upon one variable. So then you will have to compute 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, depends upon how many dependent variables are there. Then you can compute the values pertain to the leaves. You can compute, if somebody asks me to compute the values pertaining to leaf, what is the probability that you will get a leaf is probability of L equal to probability of L by R into probability of R plus probability of leave by R bar, something like the same way what we have written for this wet, that will also work. But the values, if the values are probabilities that are given are right, the predictions are also right. So then I said you have something called as Dempster-Shafer theory, which is theory that is a story that how do this Dempster use this certainty factors. That is what a Dempster-Shafer theory tell you. Like I will just share you what exactly is that story is. Very simple story, but may not be interesting for many people. Like there is a crime that was happened. You have a murder story where A, B, C, or three people are accused of that murder story. Like in the earlier case, like in the afternoon, what I said is like you have a truth maintenance system, truth justification system where we have to maintain truth based on the inferences, and after inferences you will add some values. Does that values will change the inference or not? So that is the reason I said you have monotonic systems and we have non-monotonic systems. And non-monotonic systems are systems where you have an inference. That inference can be changed with respect to time. That is the reason, if you remember, I have given a small example. Yes, yes. So in this example, I said these three statements I have given. Birds fly, ostrich cannot fly, sweetie is a bird. So from this instance, I can understand that sweetie can fly. The inference is right, but after that, I have a statement saying that sweetie is an ostrich. Since ostrich cannot fly, the sweetie cannot fly. So how do you maintain this particular truth based on the certain factors that you have? So there is a crime story called as ABC crime story where A claims that he's visiting his relative's house, that we call it as alibi. Alibi is a statement which protects the accused. B says that he is admitted into hospital. C says that he is visiting a restaurant where he has signed in the registered. B says that he is hospitalized and there are CCTV footages which are there in his favor. So A said he went to a relative's house. From there, he went to a beach where you have CCTV footage at the place. A simple story where ABC are the suspects of a crime story where the crime is a murder that has happened in Pennsylvania. And A, B, C are the people who may be involved. What is the probability that A has done the crime? What is the probability that B has done the crime? What is the probability that C has done? What is the probability that A has not done this provided B was involved and C was involved? So on and so forth. How do you use the conditional probability? When somebody asks you about a Dempster-Shafer theory, you need to write the conditional probability. Now, what is the measure of belief? What is the measure of disbelief? What is the conditional probability like? Conditional probability, you have a hypothesis to be proved and evidence was given. What is the a measure of belief minus measure of disbelief? The story that you have to write. Then there is other story saying that every day an employee starts from his house and reaches his office, and he will be back from his office to his house every day. And one particular day, he came late to the home, and the wife suspects there is something that has happened because of the delay. And the second important thing is when this particular person has reached the home, there is a stray mark in his shirt, and his wife assumes that that stray mark is a mark of a lipstick. So this employee or this husband will have his own alibis, and based on the fact that you have, based on the incomplete information that you have, what is the probability that that stray mark is a lipstick, or what the husband says is it is not a lipstick, it is something, a mark that has come from someplace. So there is a story actually. This Dempster's for theory. Theory is a story which consists of many stories. These two stories are very important. Like there is a crime that was done, and there is a wife which is suspecting her husband based on the marks that she has observed in the shirt. But what is important is what, how does we conclude with incomplete data, and how can we conclude with insufficient data is what Dempster and Schaeffer theory will guide you. And when Dempster and Schaeffer theory, if the outcome is something like, again, you need to use a certainty factor, you have to compute this measure on belief and measure on disbelief, and then you need to compute, you have to use these conditional probabilities, and then you have to compute. That's what they say. So that is what Dempster and Schaeffer theory says. If we see this particular what is this? This is to discuss the relevance of probability in artificial intelligence. You have to write about uh, the Bayes theorem, extended Bayes theorem. Then you have to write about the theory of certainty factor, and then you can give an example. Discuss the significance of certainty factor theory in artificial intelligence with an example, because certainty factor theory, you can write about how do you measure this belief, how do you measure the disbelief, and what are the formulas that are involved. These formulas you can write, and you can give an example. But whenever certainty factor was asked, you can write these stories of ABC or this wife story, which is who is suspecting